let xn equal the sine n all squared. What is the mean of x1 to x90? So what we are being asked to do is add up all of these guys all the way up until x90 and then take the mean, which obviously would be done by dividing by 90. Okay, so what I will do obviously is work with the only equation they've given me. So let's see here. I think we are going to use a trig identity, and that trig identity I'll just put on the side here. And I think it's going to be the sine of 90 minus theta is equal to cos theta. And there's another one that's probably one of the most common one in terms of what people remember, and that's sine squared theta plus cos squared theta is equal to 1. And I think these two should be sufficient. So here we go. So let's just concentrate on the numerator, and then once we have the numerator, we can just divide it by 90. So the numerator is x1 plus x2 all the way till x90, correct? Now if we group them, I think that's where this first trig identity will be utilized. So what I mean by grouping them, I mean in pairs. So x1 plus x89 plus x2 plus x88, and so on. You guys get the point. And then at the very end, I think there'll be two left over that we can't group, because we're going to eventually get to x, let's see here, 44 plus x46. And then we did not group x45, and we did not group x90. Those are sort of on their own. But these ones, all these ones, dot, 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 we did. Okay, so why did I do that? Well, we now have to use the formula that they gave me. Okay. So that's going to be sine of 1 all squared plus the sine of 89 all squared for this guy. Then we will have the sine of 2 all squared plus the sine of 88 all squared. That's that one. And then it just keeps going, dot, dot, dot. Eventually, you'll get to the sine of 44 all squared plus the sine of 46 all squared. And then don't forget the two guys that are left over all by themselves, the sine of 45 plus the sine of 90. Those are not paired with anything. Okay, so far so good. Now what? Now what we do is we use this identity here. Let me just think about this for a second. Yeah, that is the identity we're going to use. So sine of 1, we'll leave that alone for now, but this guy here, using that identity, that would become, let me think about this, sine of 90 minus theta would be, so that would be this cos of 1, right? Yeah. Because theta in this case is 1. So 90 minus 1 is 89. That's where that 89 comes from. And then if you convert it to cos, it would be the cos of 1. Right, got it. And then similarly, that sine 2 doesn't change for now, but that sine 88 would be cos of 2. And then eventually, dot, 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 a whole bunch of the sine 44 would not change, but then it would be the cos of 44 all squared. And then the sine of 45, which I can just put it in, root 2 over 2. I know that by memory, and sine of 90 is 1. And I think I have to square them, right? Yeah, I have to square them. Okay, moving right along. And then at this point, we use this trig identity. The sine squared theta plus cos squared theta is 1. Now notice, this is of that form. That would basically be 1. So is this. That's 1. And then kind of just goes on like that. And then eventually this guy would also be 1. And then don't forget that this root 2 over 2 squared would be, what is that? 2 over 4, which is a half, correct? And then the next one is 1. Okay, so now we have to figure out how many of these 1s are there. And let's see here, we went from 1 all the way to 44, so there's going to be 44 of those guys. So 44 times 1, and then we have this 3 over 2. So that would be, when you add this all up, it'll be 91 over 2. 91 over 2 is just the numerator. That's what we calculated there. So to get the mean, which is what they want, we have to take that 91 over 2 and then divide it by 90. And when you do, you get 91 over 180. And therefore the answer would be E. Suppose z is a complex number with positive imaginary part with real part greater than 1, and with the magnitude of z is equal to 2. In the complex plane, the 4.0 z squared, and z cubed are the vertices of a quadrilateral with area 15. What is the imaginary part of z? Let me just summarize this. Z is some complex number of the form a plus bi. B, they're saying, is greater than 0. And they have said that the real part is greater than 1. Okay. Magnitude of z is 2. Any other information they've given me? I think that's it. Okay, so that's a pretty decent summary. And then they're saying that they've got 4 vertices, 0, z, z squared, and z cubed. Okay, now I'm gonna have to use an example. So just an example. Let z equal something. So let's just make it simple. 2 plus 2i. And then what I'll do is I'll graph this, just to get sort of an idea. Now, this is not what z is, right? Because they want me to actually figure out the imaginary part of z. I've actually given it a value of 2, but I have to figure out what it can be. I just letting it equal this just to kind of draw a graph, because I'm not sure in my head how this will work. So then let's put in the 4 points. So 0 is obviously here. That's 0. That's the origin. Z, actually this is an imaginary number, so I've got to use real and imaginary axes. So let me just label this real, and this is imaginary. IM for imaginary. 2 plus 2i. Okay, 1, 2, 1, 2. There we go. This will be my z right here. That point right there. Z squared. Okay, z squared, I'm going to actually have to do that calculation. So it'll be 2 plus 2i times 2 plus 2i. And when I expand this, I'll get 4 plus 4i minus 4, because remember I squared is equal to negative 1. And that will give me, did I do this right? Sorry, 8i. 8i. Okay, 8i is approximately 1, 2, 3, 4, 5, 6, 7, 8. 8i is right here. So this is my z squared. Let me just put those in red so you see the points. And then the final one I have to do is z cubed. So we got this one, and this one. Z cubed, it'll basically be z squared times z. So that looks to me like 16i minus 16. So this is not drawn to scale, so it's going to be way out here somewhere. Minus 16 plus 16i, so it's going to be way up here somewhere. Let's just say it's somewhere up here. Okay, and that will be the vertices of my quadrilateral. So let's connect the dots. So that from there to there, and then and so on. There to there, there to there, and then finally all the way back to the beginning. So I guess from there to there. Okay, so this is just an approximation of what this could look like if z is indeed equal to that. That's my quadrilateral. And they're saying that has an area of 15. Okay, so big long song and dance just to kind of get basic understanding of the question, actually. It's only number 12, if you notice, but it's already getting kind of challenging. Okay, so where do we go from here? Keeping in mind that we want the imaginary part of z, so the whole question is basically asking what is the value of that b there. Okay. Now the next step, I think, will be to obviously figure out the area of this guy. And for that, I'm going to need an angle, because I think I'm going to use that formula. If you have a triangle and you have sides a and b, you can use trigonometry to figure out the area. It'll be 1/2 a times b sine theta. You guys remember that one, right? So that's what we're going to use in this question. As you can see, this shape over here, that the quadrilateral, basically is two triangles. Yeah, it's two triangles. Okay, so now let's see here. Now, if this is a kind of like a vector, right? There's a rule that every power of z rotates around the origin by the same angle. By the same angle. So that's very helpful. So for example, if this is theta, we went from 0 to that, then when it goes from that to that point, it'll again be theta. And then when it goes from that to that point, it'll again be theta. So those are all thetas in there. And that's obviously extremely helpful when we're trying to calculate the area. Okay, the next thing we're going to need is magnitude. And I think that was given, right? Right over here. That's very helpful. So magnitude of z is 2. The magnitude of z squared, you would use the properties of figuring out magnitudes of complex numbers. So that's just going to be 2 to the power of 2, which is 4. And the magnitude of z cubed is the magnitude of z all cubed. So that's going to be 2 cubed, which is 8. So that's another part of the question that is very helpful. Now, finally, we'll get to the area. And let's see here. So we got to get to the area here. Now, this up here is two triangles. If we use sort of this imaginary axis as kind of a divider, they will divide that quadrilateral into two triangles. So I'll draw it here. I just don't want to mess up that diagram. So it kind of looks like this, right? And let's see here. Kind of looks like that. So what we're kind of doing is we're dividing it in half. We're cutting it down the middle like that. Like from here to here. And then this is the first triangle that I'll draw in red. And then the other guy is the second triangle. You got it? And then this is theta. And this is theta right here. Okay, so using this formula, we will get the area. And we are told the area was 15. So that means that 15 is equal to the first area, which would be 1/2. This is 2 and this is 4. So 1/2 times 2 times 4 and sine of theta. And then the other triangle, this bigger triangle, this was 8 based on our calculations here. Correct? So that's going to be 1/2 4 times 8 sine theta. Okay, so that's very helpful. That's going to be, let's see, 4 sine theta plus 16 sine theta, so 20 sine theta. And therefore sine theta is 3/4. Okay, so we're almost done. Now we come back to the absolute basics of a imaginary number. So this is the real part. This is the imaginary part. Our number was it's always of the form a plus bi. And if that's z, then if we draw a little triangle, this over here is a, and this over here is b, and this is theta. Correct? Yeah. And therefore, we can, I guess, use, we can use the basic properties that a squared plus b squared is equal to, the magnitude of z is basically a squared plus z squared, also a square root of that. And then if we use trigonometry, sine of theta on that triangle would be b over, this is z, so b over z magnitude, and therefore b is the sine of theta times the magnitude z, and then sine of theta we just figured out was 3 over 4, and the magnitude of z, that's 2, so therefore b is 3 over 2. 3 over 2 is the answer. And let's see, what is that in terms of answer choices? That would be D. There are real numbers x, y, h, and k that satisfy the system of equations x squared plus y squared minus 6x minus 8y is equal to h, and x squared plus y squared minus 10x plus 4y is k. What is the minimum possible value of h plus k? So let's see, how can we approach this? I'll just add them. So if I add them, I will get 2x squared plus 2y squared minus 16x minus 4y is equal to h plus k. So what the minimum value of this guy, okay, I think there's going to be a completing the square. Complete the square that we have to do. Okay, let me just simplify this first if I can. X squared minus 8x, and then 2y squared minus 2y. Okay, now we'll complete the square. And you guys know how to complete the square, right? If you don't, I'll talk you through it. So you take this coefficient, you take half of it, which is minus 4, and then square that. So that would be 16. But then if you added something, you have to immediately subtract it, right? You can't change the equation. And then let's do that again. So again, this guy, minus 2, take half of that, which would be minus 1, square it. So that's 1. And then immediately subtract it. And what that allows you to do is, in a very nice way, you can square those guys. So that would be x minus 4 squared, I believe. And then kick this out of the bracket and becomes minus 32. Or on this guy, that beautifully factors to y minus 1, and then kick that out of the bracket, and that's minus 2. And then now we have 2 times x minus 4 all squared plus 2 times y minus 1 all squared, and minus 34 is equal to h plus k. Okay, so now watch what happens. The magic of completing the square. When x equals 4 and y is equal to 1, these vanish, right? Leaving h plus k equal to minus 34. And that is indeed the minimum value. And that can be figured out quickly and very clearly when you complete the square. So minus 34 is the answer, and that would be C. How many different remainders can result when the 100th power of an integer is divided by 125? Okay. So we have some integer to the 100th power, and it's divided by 125. Now, n we have no idea what it is, but 125 we know is 5 to the power of 3. Okay, so n is divisible by 5 or not. So if n is divisible by 5 or not, I guess those are the initial two categories, and there might be more categories. This is probably like the bigger one, but let's just deal with this one first. If n is divisible by 5, it's of the form 5k. And if that's the case, then we plug it back into here. It would be 5k to the power of 1 to the power of 100 all over 5 to the power of 3. And let's see, that's going to be 5 to the power of 100 times k to the power of 100 over 5 to the power of 3. And that's just 5 to the power of 97 times k to the power of 100. So you get an integer answer because remember, k is an integer. So the remainder here is 0. Remainder is 0. Okay, so that's one possible. How many different remainders are there? So one answer is 0. Okay, how many? So, okay, I got it. So we have to figure out how many other remainders are possible. Okay, how do we do that? I think this is a question that uses Euler's theorem because we have to use it in order to solve this question without having to go through every single possibility, which would be impossible. So let me explain it to you. Euler's theorem. Okay, so it says that you have the greatest common divisors of two numbers, a and n, will be equal to 1. If it is equal to 1, two numbers that have a GCD equal to 1, then a to the power of phi, this is called phi or phi, however you pronounce it, is the equivalent of 1 mod n. So I'll explain with an example. So here we go, an example to make this clear. Let's say you have two numbers. Let's choose 3 and 8. Their greatest common divisor is 1. Correct? So that basically means that we need to figure out the phi of n. N in this case is 8. Now what is that referring to? It's referring to what numbers are coprime. Numbers that are coprime with n. And in this case, n is 8. Well, I think 1 is coprime, not 2, because 2 is divisible. 8 divides 2, so they're not coprime. 3, not 4, 5, 7, and I think that's it. Yeah. So basically you're looking at the number of positive integers that are less than the number that are relatively prime to that number. And in this case, that means that this is equal to 4, because there's 4 of these guys. So that means that if we go back to Euler's theorem right here, that 3, in this case a was 3 in my example, 3 to the power of 4 is the equivalent of 1 mod n, and n in our case is 8. And you can, since this number is relatively small, you can verify it. 3 to the power of 4 is 81, and 81 is indeed 1 mod 8, because if you divide by 8, you get a remainder of 1. So I think that's what we have to use. So let me keep this in the same screen here. So in our case, we've got n to the power of phi to the 125 is equal to the equivalent of 1 mod 125. So let's explore this. The GCD of n and 125 is 1 if n and 125 are relatively prime. Relatively prime. And if n is not a multiple of 5, because we already did the multiple of 5 guy, and we want to know if it's not a multiple of 5, what happens? Okay, let's see. So if we have the phi of 125, I have to find numbers that are less than 125, that are positive, that are relatively prime. So it'll basically be anything that is not a multiple of 5. So there's going to be 125 divided by 5, which is 25 numbers that are divisible by 5. So of the total numbers, you'd have to subtract those 25, and that would be 100. Okay. So this is equal to 100. So going back to Euler's formula, we would have n to the power of 100 would be equal to 1 mod 125. Yeah. So that means the remainder would be 1. When n is not divisible by 5, which was this guy right here. And that's it. Those are the only two possibilities. You either have a 0 or a 1 as the remainder. So we have two possibilities. So the answer is B. A triangle in the coordinate plane has vertices A, B, and C. What is the area of ABC? All right, let's first talk about, let's look at these. The log of 1 to the base 2, I think that's 0, right? Because if you use log rules, 2 to the power of 0 is 1. The log of 2 to the base 2, I believe that's 1. Again, using log rules, 2 to the power of 1 is 2. So that's 0, 1. A is just 0, 1. So that's very nice. We got rid of the logs. For B, this guy I think we can't change yet unless we had a calculator. But the log of 4 to the base 2, I believe that's 2, right? Because 2 to the power of 2 is 4. So that's 2. That's nice. And let's see if we can change anything with C. This guy I don't think so. But then the log of 8 to the base 2 I think is 3. Yeah, because 2 to the power of 3 is 8. So that is 3. Okay, so we simplified it a little bit. And that hopefully will help us. Now what do they want? They want, oh, the area. Oh boy. If it was just numbers, it would be easier. And I could just use herons or something. But this is not numbers. Okay, no problem. I think I can still do it. There's a formula. If you have 3 points, x1, y1, x2, y2, and x3, y3. There's a formula that says that the area of that triangle ABC, would be equal to 1/2 times x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay, so we will use these 3 points and just plug them in. So here we go, 1/2 0, 2 minus 3 plus the log of 3 to the base 2, 3 minus 1, plus the log of 7 to the base 2, 1 minus 2. This probably should have been a square. Okay, so this leaves me with 2 times the log of 3 base 2 plus, actually negative 1 times the log of 7 to the base 2. All right. So using log rules, this will be the log of 3 squared to the base 2 plus the log of 7 to the negative 1 to the base 2. Again, using log rules, we can combine these guys, right, because they have the same base. So it'll be the log of 3 squared times 7 to the negative 1 to the base 2, all with a half out front. And then this is 9 over 7 to the base 2. And using log rules again, the 9 over 7 to the half. The half just comes out as an exponent. And then finally, that would be the log of 3. This half is basically like a square root. So if you take a square root, it will be 3 over root 7 all to the base 2. Now, what are the answer choices? This is the final answer. Log of 3 over root 7 to the base 2. Log of 3 over root 7 to the base 2 is answer choice B. A group of 16 people will be partitioned into 4 indistinguishable 4-person committees. Each committee will have 1 chairperson and 1 secretary. The number of different ways to make these assignments can be written as 3 to the power of r times m, where r and m are positive integers and m is not divisible by 3. What is r? Okay, well, first I have to understand this question. Let me see if I can. So we've got 4 committees, right? So, and each committee has 4 people. Okay, so let me just put in that. So here's the 4 committees and 16 people, obviously. And each committee will have 1 chairperson and 1 secretary. All right. So I'll call it, the chair is C and the secretary is S. So this is sort of the scenario. Okay. And then the other 2, I guess. All right. Okay, what do I do now? Well, from the 16 people, you choose 4 in order to make that committee. And then when you do, you have only 12 people left over, and you choose 4 people to make that committee. Then you have only 8 people left over, and you choose 4 people to make that committee. And then finally, you have 4 people left over, and you choose those 4 to make the final committee. And yeah, that's pretty much how this would work. And the total, you'd have to multiply them all, which would be huge number. So that like that. This is the total number of committees. But this overcounts because, well, how do I explain this? Let's say you had the first committee. Each committee, I'm going to give a letter. Let's say this was, the first committee was called Committee A, and the second committee was called Committee B, and so on. Well, this is similar to, say, A, B, D, C. You see what I'm saying? They're the same committees. It's just the order is changed a little bit, and so on. So how many different permutations you have? Well, you have 4 places for the A. Well, the first committee can be any one of 4 letters. The second committee will be any of those 3 letters. The third committee would be any of the 2 remaining, and then finally 1 choice for that last one. So the number of permutation is 24. So you have to divide all this by 24 to get the number of unique, to get a unique total. Okay, so then now we've got to actually figure out this large number here. All right, so let me see if I can do that. 16 choose, 4 choose, 12 choose. Well, 12 factorial, actually. 12 factorial, 8 factorial, 4 factorial, 8 factorial, 4 factorial, 4 factorial. And then 4 choose 4 is just 1. So I don't need to do anything there. And then that's a nice 24. Okay, that 12 cancels with that 8 cancels with that. So I'm just left with 16 factorial over, what am I left with here? 4 factorial, and looks like there's 3 of them. And then don't forget that was a 24. Okay, so we have 16 factorial. Well, 24 itself was 4 factorial. So if you invert and multiply, it would be basically 16 factorial over 4 factorial to the power of 4. Okay. That is am I fine? Well, I don't think it's the final answer, but it's getting there. I think I just looked at this, and I think I 1, 2, 3, 4. Sorry, this should have been a 4. And therefore this is a 4, And then therefore this is a 5. Aha. It's a good thing I noticed that. And there's so many 4s in there, I guess I mistakenly missed one. Okay, no problem. Life goes on. Okay, so now we think we're done, but we're actually not, because if you look at carefully, there's that condition that each committee has to have a, what is it called, chairperson and secretary? Yeah, chairperson and secretary. Okay, not a problem. And as I have listed, one person can be the chairperson and another person can be the secretary. But that actually creates a lot of combinations. So for example, let's say you have C1 and S1. There's 4 people, right? And then you have the third person and the fourth person, P3, P4. But think about it. Of the 4 people, we can have 4 choices for the chairperson. And then from the remaining 3, we choose a secretary. And then we basically, the next 2 are just going to be the regular members. So we have 4 times 3 times 1 times 1, which is 12 different ways of choosing one person to be a chairperson and one person to be a secretary. So this whole thing here needs to be multiplied by 12 for each of these. 12 for this, 12 for this, 12 for this, and 12 for this. So 12 times 12 times 12 times 12. So hopefully that made sense. And that is our final answer. And our final answer is 3 to the power of r times m. Okay? So this means this big guy, 16 factorial, 4 factorial to the power of 5, and then this is just 12 to the power of 4 is our 3 to the power of r times m. Okay. So, oh boy, so I've got to get this into the power of 3. Interesting here. All right, so how do I do that? Well, first of all, let me just go back and see what are they want r. Okay. I think I understand. Okay, so I've got to figure out, I've got to basically change this into this format to be able to get r. Since they only want me to figure out the power of r, I really only need to concentrate on how many factors of 3 are in the number on the left side. Okay, let's do it one step at a time. In the 16 factorial, that's going to be, as you guys know, 16 times 15 times 14, blah, 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 right? All the way down to 1. But what we will do, we'll only list the numbers that are factors of 3. So 12, dot, 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 9, dot, 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 6, dot, 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 and 3. And eventually times 2 times 1. So the 15, the 12, the 9, the 6, and the 3. Those have factors of 3 in them, correct? Yeah, so there's 1 here, 2 here, 1 here, and 1 here. Factors of 3. So 1, 2, 3, 4, 5, 6 total. 6 factors of 3. Okay. Now we'll concentrate on the what is it called? The denominator. And in particular, 4 to the power of 4 factorial to the power of 5. Well, that's easy. That's just 4 times 3 times 2 times 1, all to the power of 5. Well, we got 1, but it's power to the 5, so there's actually going to be 5 of those guys. So we got 5 of those. But that's in the denominator, though. And then we have this big guy, 12 to the power of 4. Well, 12 times, again, I'm just going to list powers of 3. 6, and then 3, and then 2 times 1, all to the power of 4. Okay, let me see here. 12 to the... Oh, sorry. That's not a factorial. Oh, boy. It's a good thing I didn't... That's not a factorial. That's just 12. Okay, I got it. So, that's just 12. So 12 is basically like 3 times 4, correct? All to the power of 4. So there's only one factor of 3 in a 12, and then since it's a power of 4, that'll be 4 of those guys. Okay, so that's it. Now, the numerators are this guy and this guy, so we add those, so it'll be 6 plus 4. And the denominator, which is this guy, that one, we would subtract, which is a 5. So 6 plus 4 minus 5 is 5. 5 is what this is, 3 to the power of 5. And then the m, who knows? The m, that's everything else that basically is not a factor of 3. So, therefore, after all that, we get the conclusion that r is equal to 5. And let's see if that's one of the answers. It is. A. Integers a and b are randomly chosen without replacement from the set of integers with absolute value not exceeding 10. What is the probability that the polynomial x to the power of 3 plus ax squared plus bx plus 6 has 3 distinct integer roots? So not exceeding 10. So basically what that means is that both of these guys are between 10 and minus 10. Right? So they could be anything from minus 10, minus 9, all the way till 9 and 10. So I believe that is 10, 10, and 1, 21 values that each of those could have. 21 integer values, because they're integers, right? Yeah, it says at the very beginning they're integers. All right, so that is the first part. And we want, what is the probability, blah, 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 blah. Okay. All right, so the probability of this would be the specific condition that they're asking for over the total. Now the total is probably a little bit easier to figure out. The total number of ordered pairs, A, B. For A, we have 21 values, and then randomly chosen without replacement. So you don't put it back, so then there's only 20 values left for the B. So 20 times 21 would be the total, and that's what, 420? Yeah. So that's the denominator in the probability. And then the numerator, that's going to be what we actually have to figure out. That's going to be the task of this question, actually. Okay, so here we go. So then they're saying they've got this polynomial, x to the power of 3 plus ax squared plus bx plus 6. And they want it to have 3 distinct integer roots. Okay. So let's call those roots x1, x2, and x3. 3 distinct. So they have to be different. And obviously it screams Vieta's. The Vieta's formula is going to be used here. So just to refresh your memory, if you have a cubic of the form ax cubed plus bx squared plus cx plus d is equal to 0, then the roots are r1, r2, and r3. The product of the roots, is given by minus d over a. So that, I guess, would just multiply. Sum of the roots, r1 plus r2 plus r3, sum is given by minus b over a. And the sum of the products, which is r1 times r2 plus r2 times r3 plus r1 times r3, that's given by c over a. So we're going to apply that over here and to this guy, carefully selecting the coefficients. And then when we do, we get the product to be minus 6, the sum to be minus a, and the sum of the products to be b. So this is basically the equivalent x1 plus x2 plus x3. Oh, sorry, sorry about that. X1 times x2 times x3, because the product sum, that the next one is x1 plus x2 plus x3. And then the b is the sum of the product. So x1 times x2 plus x2 times x3 plus x1 times x3, like that. Okay, all right. So now, finally, we can move forward. And really, we're just working with this now. And from the first guy, let's see here, we can kind of we have to sort of guess and see if it works out. And the parameter is that the a and b values have to be between minus 10 and 10, and they have to be integers. Okay, so one thing I immediately see is one possibility is like negative 1, 1, and 6, right? If you did that, then the product would be indeed minus 6. And if that's the case, then b would be equivalent to, you can use this formula to figure out b. It would be minus 1, minus 6, plus 6, which is minus 1. And this guy will tell you the value for A. A looks like minus 6. So is this valid, meaning does it fulfill our criteria? And the answer is yes. So this is a check mark. And that ordered pair is minus 6 minus 1. Okay, let's keep going. Another one is 1, 2, and minus 3. Again, using that first formula. And when you calculate A and B, you get A equal to 0 and B equal to minus 7. And that also is valid. It meets our criteria. Next one, 1, negative 2, and 3. That would also make this first equation valid. And when you calculate A and B, you get A equal to minus 2 and B equal to minus 5. And that also matches our criteria. The next one is negative 1, 2, and 3. When you calculate A and B there, you get minus 4 for A and B equal to 1. That also matches our criteria. And the last one, minus 1, minus 2, minus 3. That one gives B equal to 11, and that fails because remember, B cannot be greater than 10. So we got 1, 2, 3, 4. Only 4 ordered pairs that actually match our specific conditions. So when you go back, this is a 4. So when you reduce that to lowest terms, it's 1 over 105. And that is a probability, and that would be C. The Fibonacci numbers are defined by f1 is equal to 1, f2 is equal to 1, and fn is equal to fn minus 1 plus fn minus 2 for n greater than or equal to 3. What is f2 over f1 plus f4 over f2 plus f6 over f3 plus ... plus f20 over f10? Okay, I think we just have to do this manually. I don't think there is some quick formula, so we have to kind of be quick here. Okay, I'll just do it all in front of you. First, let me just figure out what are these guys. We're going up to 20, right? Okay, so it's not too bad. Because if it was very, very high, like if it went up to F100, then obviously we'd have to figure out some sort of a shortcut or some sort of a pattern. That's also common in these kinds of questions. But since it's only 20, I'll just do it manually. Okay, so these ones are 1, 1, and then you just using this recursive formula to find all the other guys. So it's going to be 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610, 987, 1597, 2584, 4181, and 6765. Okay, so let's just do it. Let's do that thing. So it would be, let's see here, f2 over, so 1 over 1 plus 3 over 1 plus 8 over 2 plus 21 over 3 plus 55 over 5 plus 144 over 8 plus 377 over 13 plus, what's the next one? 987 over 21 plus 2584 over 34 and then 6765 over 55. I should have 10 of these guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay. Then if you just add all these guys up, it's going to be 1 plus 3 plus 4 plus 7 plus 11 plus 18 plus 29 plus 47 plus 76 plus 123. And when you add up all those numbers, it is 319. Therefore, the answer is B. Equilateral triangle ABC with side length 14 is rotated about its center by angle theta, where theta is between 0 and 60 degrees, to form triangle DEF. See the figure. The area of hexagon ADBECF F is 91 root 3. What is tan of theta? I will draw a few lines in here. Hopefully they will help. So the first line is from the center to F. And the next line will be similar, the center to C. And just to illustrate that is the rotation that has been made. We took A, B, C, and we rotated it to form D, E, F. So we basically, it doesn't matter which way you're going, if you're going this way or that way, but we went theta. It doesn't really matter which way you went. I am thinking they went from C to F, which is fine. Okay, that takes care of that. And I'm going to draw another line. I'm just trying to think which one. This one should be sufficient. That is the other one. And then the other lines I'm going to draw, but I'm going to draw the different color because it has to be differentiated. So to B, and then to D, and then finally 1 to A should be enough to figure this out, hopefully. Okay. Hopefully you can see those. All right, so now we have to discuss this a little bit. So the red lines make up two triangles, right? I need to call something, I'll call the center O. So it makes up O, let's see here, what are the triangles? OFC, and the bigger one would be OEC, or OCE, doesn't really matter, OCE, right? Those are the triangles that are involved with the red lines. Now, if you look at the diagram carefully, if you add those up and then multiply by 3, it would be the entire diagram. Because if you look at the other triangles, they're identical. See, OEB plus OBD is the same. And then similarly, OAD plus OAF would be the same. So if you add all these guys up, it would be the whole thing, which is A, D, B, E, C, F. Okay, so that's sort of just the initial setup. All right. Now I think we're going to need an angle in here. And I'm just trying to think, how would we get that angle? Okay, from here to here, did you see that, what I did there? That is 1/3 of the full rotation, correct? Just because of the symmetry of this diagram. If you went all the way around, it'd be 360, but that green line that I drew in is 1/3. So that is 120. So therefore, from here to here would be 120 minus theta. Yeah. And doing this, deliberately doing this slowly so you can understand. Okay, then next, what's the next step? I think at this point, we're going to need to use some algebra. And there's a formula you guys may remember that if you have a triangle, and this is an angle, and we have sides A, B, and C, the area of that triangle can be calculated with trigonometry as 1/2 AB sine theta. So that's the formula we're going to use. And we're going to use it on OFC and OCE. So here we go. Let's move this up a bit. So 3 times the area of OFC plus the area of OCE is going to be equal to, and they gave me the total, right? 91 root 3. So that's very helpful. So 91 root 3. Okay, so here we go. So we got 3 times OFC, so we've got 1/2 times OF times OC sine theta plus 1/2 OC times OE sine of 120 minus theta. And that's 91 root 3. And we need a whole bunch of okay, I got it. We need a whole bunch of values here. So without making the diagram too messy, I'll do it over here. So let's just draw an equilateral triangle like that, and this is F, let's say, and this is D, and this is B. And they told me in the beginning of the question that the equilateral triangles have a side length 14. Okay, no problem. But it's the same equilateral triangle, ABC, and then DEF. So that means this is 14 right here. This is 14. This is 14. Now, I'm interested in, what am I interested in? First, I need to figure out the length of that. Yeah. And then, eventually, we're going to have to figure out the length of this guy right here from F to that point, which is O. See, it's O here. And that, I think that's called a centroid. Centroid. O is representing the centroid of the triangle. And since I drew a perpendicular, this will be split into halves, so this is going to be 7. So I can use Pythagoras to figure out that height from that top to bottom. So that's going to be 8 squared plus 7 squared is 14 squared. And that means h, if you calculate this, will be 7 root 3. Now, but I'm not interested in top to bottom. I just want that red part. You see that red part. But the good news is that the centroid has a property that it's in the ratio 2 to 1. So that red part is really 2/3 of the total. So that means OF would be 2/3 of that 7 root 3. So that's going to be 14 root 3 over 3. Okay, so all that hard work to get OF. And by symmetry, this OC is the same. So we got 1/2 14 root 3 over 3, really squared, because since OC is the same as OF. Sine theta. And let's see here. Oh, wait, we got to do this one. Same thing. OC is the same as OF, and OE is the same as OC. So again, we can use that 14 root 3 over 3 value. But this is sine 120 over 120 minus theta. And it's all equal to 91 root 3. Okay. I think we're getting somewhere. So now let's do this math. So we got 3 is equal to, that's going to be, oh boy, I got to crunch out these numbers. 3, 196 over 9. It's 196 over 6 sine theta. And this one is also 196 over 6, but it's sine 120 minus theta. And that's all 91 root 3. All right. Let me just remind myself, what am I trying to figure out? Oh, eventually we have to figure out tan of theta. So we're essentially just trying to chase the angle here. Okay. It's got this in here. That's a huge headache. Well, I guess I have to use some, what's it called? Trig identity, which is sine A minus B is equal to sine A cos B minus cos A sine B. Remember that identity? That's what we're going to have to use there. So this will be, let me do this carefully here. I don't want to mess this up. Actually, let me get rid of this 3. Let me just put that 3 out here. 91 root 3 over 3. That gets rid of that 3. And now I can just do this. Actually, let me get rid of the... First, let me just do that. That gets rid of the 3. And then multiply it by that 6 and 196. That way I can get rid of these guys. And that will just leave me with the sine of theta plus the sine of 120 minus theta. Yeah, that's really helpful. Okay. Now we can use the trig identity. So this one, when you crunch out the numbers, it's 13 root 3 over 14. Okay. And then the sine of theta, we're going to leave that alone for now. And then on this guy, we have to apply this trig identity. Okay, so let's see here. Sine of 120 cos theta minus the cos of 120 sine theta. Got it? So sine of theta plus root 3 over 2 cos theta minus 1/2 sine theta. All right. And then, can I clean this up a bit? Yeah, sine theta plus root 3 over 2 cos theta. And then plus that. That's all I can do right there. And then I can add them. So it'll be 3 over 2 sine theta plus root 3 over 2 cos theta. And at this point, anything else I can do? If I multiply through by 2 and divide by root 3, so if I multiply everything by 2 over root 3, then that will allow me to, let's see here, this will become root 3 sine theta, this will become just cos theta, and then the other side would become 13 over 7. Okay, that's nice. And then now, oh boy, they're really making me work on this one. I guess I can square it, right? Yeah, so I have to isolate in terms of cos theta, 13 over 7 minus root 3 sine theta, and then square both sides. And that would be 169 over 49 minus 26 root 3 over 7 sine theta plus 3 sine squared theta. And then you use that famous identity, cos squared theta plus sine squared theta is equal to 1. So this becomes 1 minus sine squared theta. And finally we have just one trig value, which is our sine. And then, oh, this is a quadratic. Painful. So put everything on one side, and we get 4 sine squared theta minus 26 root 3 over 7 sine theta plus 120 over 49, I believe. Yeah. And then you're going to use a quadratic. Using a quadratic, you will solve this to sine theta is equal to 5 root 3 over 14. So that means that you have a triangle, a right triangle, and this is theta. Sine is 5 root 3 opposite over hypotenuse. Using Pythagoras, you can easily get the value for x. You'll get x equal to 11. So therefore the tan of theta is opposite over adjacent, so it'd be 5 root 13 over 11. 5 root 3 over 11, and that would be choice B. Suppose A, B, and C are points in the plane with AB equal to 40, AC is 42, and let x be the length of the line segment from A to the midpoint of BC. Define a function f by letting f at x be the area of ABC. Then the domain f is an open interval PQ, and the maximum value of R of f at x occurs when x equals s. What is P plus Q plus R plus S? So AB is equal to 40. AC is equal to 42. And f at x is equal to the area of triangle ABC. Correct? And the domain of f is in the interval PQ, open interval, and the max value R of f is when x is equal to s. And then finally they want us to figure out P plus Q plus R plus S. Okay, let's see what we can do here. So we are going to use, let's see here, two formulas. So those two formulas will be AMGM and Heron's. So the first one is Heron's. Heron says that if you have a triangle with sides A, B, and C, its area is equal to S times S minus A times S minus B times S minus C, all under the square root sign, where S is half of the perimeter. Okay, that's Heron's. AMGM is arithmetic mean, geometric mean. Arithmetic mean, geometric mean. And its formula says that if you have two numbers, A and B, that their actual, the arithmetic mean, which is calculated by A plus B divided by 2, will always be either greater than or equal to the geometric mean, which is defined as the root of A times B. And it's equal when A is equal to B. Okay, so those are the two formulas we're going to use. So the first thing I guess I would have to do is figure out the what am I going to figure out first? I guess the area. Yeah. But I actually don't know the third side. If I have a triangle like this, and this is, say, A, and this is B, and this is C, and this is 40, and this is 42. I don't know the third side. So I just have to give it some variable. I'll just call it A or 2A, since I'm going to be calculating a semi-perimeter to avoid fractions. So therefore S would be equal to 40 plus 42 plus 2A all over 2. So that's going to be 41 plus A. And therefore the area, using Heron's, would be 41 plus A times 41 plus A minus 40 times 41 plus A minus 42 times 41 plus A minus A, if I've done that correctly. Oh, minus 2A, sorry. Minus 2A, because 2A. And then all under the square root sign. So that is 41 plus A times 1 plus A times A minus 1 times 41 minus A, all under the square root sign. And that looks to me like A squared minus 1 times 41 squared minus A squared, all under the square root sign. Okay, now we can concentrate on the domain at this point. So the domain is basically, what can this be? Since everything's under the square root sign, those have to be positive, because you can't take the square root of a negative number, right? So that means that A squared minus 1 has to be greater than 0, therefore A squared is greater than 1, and therefore A is greater than 1. And then also 41 squared minus a squared has to be greater than 0. So that means 41 squared is greater than a squared. So that means 41 is greater than a. So if we combine these two, a has got to be greater than 1 and less than 41. So that is my domain. So PQ, I guess I'll write it in red since it's a big finding for us. The PQ, the domain, is between 1 and 41. So that's very helpful. Now we have to figure out this guy here. We figured out this one. That's 1 and 41. Now the max of R of f is when x equals x. So we have to figure out when is the max, and that's where we use the AMGM, arithmetic mean, geometric mean. Okay. So we have two numbers, right? And this guy right here, take a look at this guy right here. This looks very similar to this guy here. So I'm going to use a, well, I'll just write them down. A minus 1 and 41 squared minus a squared. Those are my two, I guess, numbers. And therefore, using AMGM, if you add them, which is this guy, a squared minus 1 plus 41 squared minus a squared all over 2, that has to be greater than or equal to that whole thing. Oh, I can't fit it in. So I'll just write it down here. A squared minus 1 times 41 squared minus a squared. You guys understand. Okay. So using that, if I clean this up a bit, I get 41 squared minus 1 all over 2 is greater than or equal to this guy, which is the area. Yeah, which is the area. And the area is basically f at x. So I can just put f at x here. Yeah, combine it all together. So 41 squared minus 1 divided by 2 is 840. So that means f at x is less than 840. So that means the max value, max of f at x, is 840. So that means this r is 840. Now the last piece of the puzzle is trying to figure out s. We know the max is 840, but when does that occur? For what value of x? Well, it's less, if you pay close attention to there, it says that f at x is less than or equal to. We're saying f at x is equal to 840. That is the max, correct? Yeah, maximum. But when is it equal? It's equal right here. It's equal when those two numbers that we're comparing are equal to each other. And those two numbers that we're comparing are this guy and this guy. So to figure out the value of when it is equal, we have to set those two equal to each other. So a squared minus 1 has to be equal to 41 squared minus a squared. So that gives me 2a squared is equal to 841. No, not quite yet. It's 1682, and then when I divide by 2, it becomes 841. And then when I square it, hopefully it'll give me an integer. It does. A is 29. So when a is 29, that's when we get the max. So that's this part. That means when s is equal to 29. So we got all the pieces of the puzzle here. And then the question wanted me to figure out p plus q plus r plus s. So p plus q plus r plus s would be 1 plus 41 plus 840 plus 29. And that is 911. And that would be C.